Have you ever wondered what will happen to the universe in the end? It's an intriguing question, isn't it? Our universe, this vast cosmic expanse, is in a state of constant change, ceaselessly evolving and transforming. Everything we see around us, from the smallest particle to the largest galaxy, is part of this grand cosmic ballet. But what does the future hold? What will be the ultimate fate of the universe we inhabit? These questions might seem daunting, perhaps even a little terrifying, but they're crucial to our understanding of the cosmos and our place within it. There are several theories about how it all might end, each with its own set of implications and consequences. From the chilling prospect of a heat death to the cataclysmic potential of a big crunch, or even the unsettling Big Rip scenario. So, buckle up as we journey through the cosmos and explore its potential destinies. Imagine a universe where all the stars have died out and everything has cooled down to the same temperature. This chilly scene is what scientists refer to as the heat death of the universe. It's a concept born from the laws of thermodynamics and entropy. Entropy, in its simplest form, is a measure of disorder. The second law of thermodynamics states that within a closed system, like our universe, entropy will always increase. Picture a sandcastle on a beach. Over time, the wind and the waves will inevitably reduce that structured sandcastle into a chaotic pile of sand. That's entropy at work. In terms of the universe, the stars and galaxies we see today can be compared to the sandcastle. They represent order, but as time marches on, the energy in the universe will spread out and the stars will burn out. This energy dispersal is the process of increasing entropy. So what happens when entropy reaches its maximum level, when all the energy in the universe is evenly spread out? Well, there'd be no room for the processes that drive life as we know it. Stars can't form because they need a higher concentration of energy. Planets can't support life because they need the energy from a star. Even atoms might cease to exist. Now, this might sound like a doomsday prophecy, but it's important to remember that if the heat death scenario is indeed our universe's destiny, it won't happen for an inconceivably long time. We're talking about trillions upon trillions of years into the future. So, why bother thinking about it at all? Well, understanding these concepts gives us a deeper insight into the laws that govern our universe. It reminds us of our fleeting existence in the grand cosmic timeline and underscores the importance of making the most of our time in this structured, ordered universe. So, in the end, the universe might just fade out like the last embers of a dying fire. But until then, there's a whole lot of cosmic story yet to unfold. But what if gravity, the cosmic glue that holds everything together, eventually wins out? This brings us to the Big Crunch theory, a fascinating and fiery end of the universe scenario. Gravity, as you know, is the force that tethers us to the Earth and keeps planets orbiting around stars. It's also the force that's trying to pull everything in the universe back together, fighting against the cosmic expansion. If gravity were to overcome this expansion, we could potentially witness a big crunch. In this scenario, the universe, instead of expanding indefinitely, would start to contract. Imagine a balloon inflating, representing the universe's current expansion. Now picture that same balloon gradually deflating, everything inside it coming closer together. That's the Big Crunch in a nutshell. As the universe contracts, galaxies would start to merge, stars would collide, and everything would become progressively denser and hotter. The universe would essentially be returning to its original state, a singularity, just like before the Big Bang. This would have some pretty dramatic implications for matter and energy. The laws of physics as we know them could cease to exist, replaced by new laws in this ultra-hot, ultra-dense state. It's a bit like hitting the cosmic reset button. However, it's important to remember that this is just one of many theories. The actual fate of our universe remains a mystery, waiting to be unlocked by future scientific discoveries. In this scenario, the universe's curtain call might be a spectacular, fiery crunch. Yet there's another possibility, one where the universe doesn't go out with a bang or a whimper, but a rip. Let's start with dark energy. This enigmatic, invisible force makes up about 70% of the universe. While we can't see it, we know it's there because of its effect on the cosmic landscape. Here's the kicker. Dark energy is responsible for the accelerating expansion of the universe. But what if this force doesn't remain constant? What if dark energy becomes stronger over time? That's where the Big Rip hypothesis comes into play. This theory suggests that if dark energy continues to increase, it could eventually overcome all forces of attraction. Gravity, electromagnetism, even the strong force that binds the atomic nucleus. All could be torn asunder by the relentless expansion. Think of it like this. The universe is like a loaf of raisin bread dough. As it bakes, it expands, and the raisins move farther apart. Now imagine if the dough kept expanding without end. The raisins, galaxies, stars, planets, and ultimately all matter would be stretched into oblivion. So what would this big rip look like? Initially, galaxies would be torn apart as the space between them expands. Then, the individual stars would be flung out into the cosmic void. Eventually, even atoms themselves would be ripped apart, leaving a universe filled with isolated particles, drifting in a sea of increasing darkness. However, don't start panicking just yet. If the Big Rip is indeed our universe's destiny, it wouldn't occur for another 22 billion years or so. That's quite a bit of time to enjoy the cosmos as we know it today. In the grand scheme of things, the Big Rip paints a picture of a universe not gently fading into the night, but being inexorably torn apart by the very force driving its expansion. It's a stark reminder of the ultimate fate that awaits all things in a universe governed by entropy and time. If the Big Rip happens, the universe could literally tear itself apart. These aren't the only theories, though. Some suggest even more exotic ends. For instance, there's the concept of vacuum decay. This theory proposes that a quantum event could cause a shift in the energy state of our universe. The result? A destructive bubble of true vacuum that expands at the speed of light, obliterating everything in its path. Then there's the cyclic model, imagining the universe as an eternal series of big bangs and big crunches, forever oscillating between expansion and contraction. Some even suggest a quantum theory of gravity, which could potentially reconcile the contradictions between quantum mechanics and general relativity. The truth is, there's a lot we still don't know. Our understanding of the universe is constantly evolving, with each new discovery bringing us closer to the answers. Scientists all over the world are working tirelessly, piecing together the cosmic puzzle. Regardless of the theory, one thing is clear: the universe's future is a grand mystery waiting to be solved. So where does this leave us? We've journeyed through the chilling prospect of heat death, the cataclysmic potential of a big crunch, and the unsettling hypothesis of a big rip. We've also dipped our toes into the sea of other theories and speculations, reminding ourselves that our understanding of the universe's fate is still evolving. As we ponder these theories, we realize that our place in the cosmos is both insignificant and profoundly precious. After all, it's the only universe we've got.